Good morning, everybody. My name is Janice Bong. Today, Kiming and I will be explaining the question 8 of Simulation and Credibility Theory Computer-Based Test. The question 8 is shown here. The question 8 is talking about S is the random variable denoting the number of claims in one day. The following is a sample of the number of claims occurring on 5 randomly chosen days. The following estimate from a sample of n days is used to estimate probability of s less than or equal to 4. The bootstrap approximation is applied to estimate the mean square error of data using the following 25 samples simulated from the empirical distribution of the original sample. So here is the sample given, and the question is asking us to find the bootstrap approximation to the mean square error of the estimator. And we use Excel to calculate the answer. For the empirical distribution, there are 3 out of 5 days with number of claims less than or equal to 4. Therefore, the parameter theta Fn, which is also the probability of number of days with the claims less than or equal to 4, is equal to 0.6 now. Then, we need to calculate the expected square difference under the empirical distribution. There are 25 possible samples of 5 days simulated, and each sample has a probability of 1/25. There are 2 steps to calculate this expected square difference.
First, we highlight the days and we use the conditional formatting with the rule less than 5, which is equal to 4 claims or less. The number of days with 4 claims or less will be highlighted. Secondly, we will be using the COUNTIF function with the range of 5 days and the criteria of less than or equal to 4 for every sample. This G1, Gx1, x2, x3, x4, x5 is actually the probability of the number of days with 4 claims or less in every sample, and it is calculated by dividing the number of days with 4 claims or less by the total number of days. To get the O data, we just drag it down. Next, we compute the square difference between the Gx1, x2, x3, x4, x5 and the theta Fn of 0.6. We log the theta Fn and drag it down. Finally, the MSE cap, which is the mean square error, is obtained by 1/25, which is the sample probability of the sample times the sum square difference